This is a super cheap unofficial Arduino Uno board that I picked up on AliExpress for like $2 and change. This is the official Arduino Uno R3 that I got from the Arduino store. Today I'm going to take a look at both of these things, see how they stack up compared to one another, and if there are any real differences between the real deal and a super cheap alternative. Let's check it out. So I happened to be on AliExpress looking up something completely unrelated at the time when this little Arduino Uno popped up for something like $2.40, around there. And I thought, that's amazing. I have difficulty imagining how they can make an actual Arduino Uno R3 board for, $2 and change. That sounds incredible to me. So I thought, what the heck? I placed the order, waited a few weeks, here it came. And not only did I get that, but I wasn't really paying attention when I ordered it. It even came with the neat little, USB cable thing, which leads me to believe that they're actually manufacturing this for, under $2. I mean, $1.50 maybe, something around that. Their margins must be incredibly slim on making these, which makes me wonder, did they cut a lot of corners? And if so, what sort of difference will I see in performance when I compare it with an actual Arduino Uno R3 that I picked up from the Arduino store? And now this is just going to be a quick video, quick comparison, because I was curious. I don't really have the stuff in the lab to do some sort of like really detailed analysis between the two different boards, but that doesn't mean that I can't just take a quick look under the macro lens and maybe just check out a couple of the little, differences that we might see here and see if they really amount to anything. Actually, the thing that we should keep in mind here is that Arduino Uno is an open source platform, so it's no big deal that there are, manufacturers around the world who make these things for such a small amount of money. And of course, you can take the schematic online, and I'll link it in down below, and build your own anytime you want. But you're going to be hard pressed to do it for like less than $3. I mean, you're really going to be hard pressed to do it for less than $10 unless you buy some of the components in bulk and make a, a pretty good number of Arduino boards for yourself. So, what is it that they changed on here to get the price so low? Or is the actual Arduino so expensive simply due to marketing and, I don't know. I don't want to say corporate greed because, this is an open source board, but they're paying for something here. Maybe the guy who made the logo? I don't know. And now the first thing I did when I got these two boards together was just take a simple look at, the components on the surface. It's really only a one-sided board, so it's easy enough to scout around and see if there's any visible differences between the two things. But the truth is, in terms of actual construction, I find there to be almost no difference. You can see that the pin headers on the official board are a little bit nicer. They come in these, one-piece sort of sections, whereas there's a couple sections on the cheaper board, and those don't line up exactly. So, you'll probably have to push a little bit to get a shield board connected to that. And also, on the official board, you get the nice pin out that's written directly on the pin headers, and that can be nice. If you have a shield on there and you're not really clear what pin is what, that helps you see. You can see when I zoom in to the programming IC that they have on these boards that yes, there is a little bit of difference in the soldering around the surface mount components, but it's very minimal. It's not sloppy. It's been cleaned. It looks like it's been cleaned very well. I find that really surprising. I honestly expected to find some residue or some, dry, cracked solder joints or something like that going on this board, but there's really nothing at all to complain about. Even the masking is pretty nice. If you take a look at the back of the board, I mean, really, that's not too bad at all. So, okay, if the quality of the actual board itself looks roughly similar, can you notice any difference in components? And now here's where that schematic comes in handy. Since this is an open source platform, we can actually take a look at the schematic and see if there's anything missing, if there's any differences between the two boards. And once again, I gotta tell you, shocked. There are actually two components present on the official Arduino board that are not present on the less expensive alternative board. You'll notice on the official Arduino board, there's a tiny ferrite bead that's attached to the 5-volt line. And if we take a look on the cheap alternative board, there is not a ferrite bead present there. And actually following that same line around to the VCC pin on the AT-Mega 328P, we see that there is a bypass capacitor on the official Arduino board that again is not present on the cheap alternative. Now, while there might be some variation in manufacturer and the components on the rest of the board, these are the only two real material differences on these two boards. And now really the only difference that I can see in adding those two components to the official board, it just means that if you wanted to power this board using the 5-volt and ground pins on the header, instead of say using, the USB in or the AC adapter jack that they have on here, the barrel jack, then if there was noise on that supply, that would make it through to the actual microcontroller and might cause you problems. But since that seems like a very rare scenario and, most people do not power their Arduino that way, I think that that's only going to be a very minor difference between these two boards. And I can actually, I can see why they would have excluded it on the cheaper alternative board. And further, actually, I think the decoupling capacitor is actually present on the official Arduino schematic. This ferrite bead is not, and so it makes sense that they wouldn't include it on this board since it's not part of the official schematic. So now what about the actual components they use? Maybe those are a little bit different. And here we actually do see a little bit of difference. You can see that on the cheaper board, they've used slightly different components for, the voltage regulator, for the transistor that's present. The LM358 is just a generic LM358 on the cheaper one. And I'm sure all the other components are kind of like the cheapest they could get away with. So the capacitors are likely a lot less expensive. And even down to like the LEDs, I can see that they're different and that the ones on the cheaper board are likely a little bit cheaper. But all of those components are probably still within spec. I tested some of the capacitors and the resistors to see if there was any big difference, and there's really not. In fact, some of the ones on the cheap board are closer to the schematic than the ones on the official board, but it's all well within tolerance, so none of that looks like a big deal. And I actually expected the voltage regulator to be different enough to possibly make a difference, but they use a pretty well-known voltage regulator on the cheap board. It's a variant of the LM1117. It's marked AMS 1117, and I'll link in a datasheet if I find one on here somewhere. But I've seen these in a number of other devices and ones that aren't even particularly cheap. So, I'm pretty comfortable with that thing and that it's going to work the way it should. And of course the AT-Mega 328 that's actually, on the board, the actual microcontroller that powers your Arduino, those are the same on here. There's no obvious evidence that the one on the cheaper board is a forgery or anything like that. And that's not surprising. You can get AT-Mega 328s in large quantities for next to nothing. And my guess is that the type of people who can put a board like this together can probably find them much cheaper than I can. And so that really only leaves one possible source of difference between these two boards, and that's in the crystal oscillators. And now luckily the oscilloscope I have can do FFT pretty well, so I went ahead and probed these as best I could to try to get relatively consistent results. You can see here on the spectrum analyzer on the scope that on the official board, the harmonics for the oscillator on that board are a little quieter than the harmonics on the cheap board. But now notice that even on the cheap board, the second harmonics and the ones after that are 40 dB quieter than the root frequency of 16 megahertz. And that means that this is going to make no real difference. And likewise for the other oscillator, we see that we get almost the exact same results. And since, the one that's present on the official board isn't exactly a precision crystal to begin with, we're not going to see any real difference in terms of performance. So that pretty much does it. These boards are almost identical. So now the next time you need yourself an Arduino, at least an Arduino Uno R3, I guess I highly recommend that you hit up AliExpress and buy, maybe 6-10 of these for the price of one of these guys. There's no material difference other than the extra money that you put into this probably goes into other development, probably makes the Arduino IDE a little bit better and some of the libraries a little tighter and all that good stuff. But if you're trying to do something for the absolute minimal cost, yeah, I would definitely go ahead and pick up, a bunch of these guys. And that'll do it. I'll put some links down in the description to these guys. They won't be affiliate links, so feel free to look these up wherever you can. I hope you liked the video. If you did, give it the thumbs up, subscribe, the alerts bell, comment down below, and all that good stuff, and I will see you next time.